access. To start out the VPN configuration on our home router, I'm going to go ahead and turn on IPSec. That's the Internet Security Association Key Management Protocol. It's not bound to any specific cryptographic algorithms, key generation techniques, or security mechanisms, so this is highly upgradable and adaptable to a changing technology and environment. That's one of the great benefits to IPSec and IPSec and just VPN technology. So whenever something changes, they can easily just swap out with a new technology or algorithms as they become more secure, and there's no compatibility or functionality issues there. If you want to read a little bit more about IPSec, you can check out RFC 2408, or if you just want to get a good night's sleep, go ahead, print that out, read a few pages, and I'm sure you'll be sleeping like a baby in about 10 or 15 minutes. So we will enable that, the IPSec enable. The next thing that we're going to do here is define our IPSec policy. So crypto IPSec policy, and we'll give it a policy of 10. Next, we want to define the encryption method, and we're going to use AES as I mentioned earlier. For the authentication method, we will use the pre-shared key. For the Diffie-Hellman group, one of the requirements here for the key distribution method, we'll do group. You can see set the Diffie-Hellman group, and we will use 2. For our hash method, we will use SHA, and we'll set the lifetime. Lifetime default is set to 86,400 seconds. The next thing that we're going to do here to wrap up phase 1 is define the key that we'll be using for the pre-shared key and set the remote site. So we'll go crypto IPSec. We'll set the key, specify that it's going to be unencrypted text, and we'll set the key to Bowler CBT Labs. And our peer address is going to be the interface of the router that's it's connecting to the internet, or the outmost facing interface here. So the 10.1.1.1 interface is going to be peering with the 10.2.2.1 interface on the office router. So we'll just go ahead and do that. Alright. Now to begin the phase 2, here we will create the transform set by defining the crypto IPSec transform set, and we'll give it a name. We'll just call it the VPN set, keep it simple. And we'll be using the encapsulating security payload with triple DES and ESP SHA HMAC. Okay. The next thing that we'll want to do here is back out and define the security association lifetime. So we'll do crypto IPSec security association lifetime, and it's going to be seconds, so we'll define it by, and just go with the max there, 86,400. This next step, defining interesting traffic, is basically a way of telling our crypto map what IP addresses or what type of traffic to look for when encrypting and encapsulating the data. So in this example, I'm only going to encrypt data passing between the 172.16.1.0 network, so everything from this side heading across the network and with the destination address of this network over here, the loopback adapter. We'll just pretend there's a whole other network out there, and there's more than just my laptop on this side. So we'll say anything that's passing from this side of the network, the 172.16.2.0/24 network, headed towards this network is going to be encrypted. And we can accomplish that by creating an IP access list. It's going to be an extended access list, and we'll call this let's call it VPN traffic. And I'm going to permit IP traffic sourcing from, can you take a guess and determine which IP address we're going to say the originating traffic should be from? For on the home network, the source traffic is going to be from the 1.0 network, saying anything from that network with that wildcard mask to the 172, which is going to be the destination address, 172.16.2.0, and anything on that network. And it's as simple as that. So our next step here is going to be creating the crypto map, and we'll go ahead and make the crypto map and just call that VPN map. Sequence 10, we'll just start at sequence 10.